Here's number 20 from section 2.4. A particle moves along a line so that its position at any time t greater than or equal to 0 is given by the function s of t equals negative t cubed plus 7t squared minus 14t plus 8, where t or s is measured in meters, t is measured in seconds. Let's begin with part A. Find the instantaneous velocity at any time t. We're starting to get in the habit of seeing instantaneous velocity and immediately thinking derivative. So what is the derivative at any time t? They just mean find the general derivative here. So we can label this velocity, or we can label it s prime, the derivative of position. And we're going to get, by the power rule, negative 3t squared. And then the derivative of 7t squared would be plus 14t. And the derivative of minus 14t is going to be minus 14. And the derivative of 8 is 0. So part A is done. B, we want the acceleration of the particle at any time t. So the acceleration function we know is the derivative of the velocity function, derivative of v, or it's the second derivative of position. So whether we label this as a of t, v prime of t, or s double prime of t, we're all talking about the same thing. It's acceleration. And by the power rule, this acceleration is going to be negative 6t plus 14. Next, part C, when is the particle at rest? At rest. That means it's not moving forward and it's not moving backward. It's maybe taking a pause. Maybe it's moving right and then changing to left. Maybe it's moving left and then changing to right. Or maybe it's moving right, slowing down, taking a little pause, and then continuing to the right. It could be any of those. But either way, the velocity is going to be 0. We're going to see no sign on that velocity indicating forward or backward movement. It's just going to be 0. So what we want to do here is take the velocity function, negative 3t squared plus 14t minus 14, set it equal to 0, and solve. So this doesn't factor, which means we have a couple of options here. I've got an option of the quadratic formula, which is a good option. We could do that. Or we have the option of our graphing calculator. So I'm going to choose graphing calculator in this condition. And for the quickness of getting this video done, I'm going to tell you that solving this with my graphing calculator gives me two possibilities. That t is approximately equal to either 1.451 rounded to 3 decimal places or 3.215 rounded to 3 decimal places. So those are the two places, or the two times in seconds when the velocity is equal to 0. Last, for part D, describe the motion of the particle and at what values of t does the particle change direction. So I like to look at it this way. Let's think about a number line that just contains times. And we know we start at time equals 0. And we know that we have a velocity that's 0 at second 1.451. And we also know we have a velocity that's 0 at second 3.215. So I'm wondering what the sign SIGN, whether positive or negative, is the velocity in the intervals. What is the sign of the velocity between 0 and 1.4, between 1.4 and 3.2, and then after 3.2? Maybe that gives me an idea of the motion of the particle. So let's pick a test value, something between 0 and 1.4. I like 1. So what is the velocity at 1? I'm going to just kind of work through this mentally. So if I plugged in a 1 to the velocity function, that'd be a negative 3 times 1 squared plus 14t, or 14 times 1 minus 14. So negative 3 and then plus 14 minus 14. That's negative 3, but really my takeaway here is that the velocity is negative. Between 1.4 and 3, I'm going to use a test value of 2, so v of 2. It's going to be a negative 3 times a 2 squared plus a 14 times a 2, and then minus 14. Let's see what we have. This is going to be negative 3 times 4, so negative 12. Negative 12 plus 28 minus 14. That's going to be a 2, and that means we got positive here for our velocity. Finally, something after 3.2, how about a 4? So let's try a v of 4 and see what we get there. V of 4, so negative 3 times a 4 squared plus 14 times a 4 minus a 14. I think it's pretty easy to see here that this is going to end up being negative. We have negative 3 times a 16, that's negative 48. And then we have a 14 times a 4, so that's plus 56. We're in the positives now, but subtracting another 14 gives us a negative number. So these are the signs of the velocities, and that means that our particle moves left, changes direction and moves right, and then changes direction again and moves left. So how do we describe the motion of the particle? We kind of just did it. Particle begins moving left, changes direction to right at t equals 1.451, and changes direction again to left at t equals 3.215. It continues left forever. There's our particle, and there's the motion for part D, and that's number 20.